Okay, we recently have looked at some quadratic expression integrals, and we included that under our series of trigonometric substitutions, because a lot of times they can be manipulated algebraically into a form that's amenable to a trig substitution. And here we have a problem where we have the integral of x plus 1 divided by the square root of 2x minus x squared dx. So you can try to use a UDE substitution. That did not seem to work out for us. That means we're going to manipulate this here, the expression inside the square root sign. And the first thing I like to do is rewrite it like this. 2x minus x squared, rewrite it as minus this quantity, x squared minus 2x. Now we go ahead and attempt our complete the squares type operation. Take half the coefficient of that, that would be 1. So we have x minus 1 squared, and this gives x squared minus 2x plus 1. So if I subtracted 1 from this, that will equal x squared minus 2x, because I subtract the 1 here. So we can rewrite this as this equals minus this quantity, x minus 1 squared minus 1, and we can multiply through by negative 1, get 1 minus x minus 1 squared, and that was under a square root sign. So we can rewrite the integral now. This square root here is equal to this square root here. So this integral now looks like this. Integral of x plus 1 divided by the square root of 1 minus x minus 1 squared dx. Now maybe we're in business, because here we have an integral where under the square root sign we have a constant 1 minus x minus 1 squared. Treat that as just a variable squared. And if we look up here at our basic trig identities, obviously that resembles this one where I have a constant 1 minus a variable squared. So we come along and say, let x minus 1 equal the sine of theta. So this is going to be 1 minus the sine squared of theta. That's the cosine squared of theta. If we take the square root of that, this part turns into the cosine of theta. And if x minus 1 equals the sine of theta, to get x plus 1, we add 2 to both sides. So x plus 1 equals 2 plus the sine of theta. So this part of the integral, 2 plus the sine of theta. And what about dx? That's easy enough to find out. We go to here. Dx equals cosine of theta d theta. So we can transform this integral. We have 2 plus the sine of theta times dx, and that's this, cosine of theta d theta divided by this, and the cosine of theta. So with this substitution, this integral becomes this integral, and these cancel out, and looks like we can do the rest in our head. This equals 2, the integral of d theta, that will equal 2 times theta. And then we have the integral of the sine of theta d theta, that's minus the cosine of theta. So, again, once you could manipulate this into this form here, that set us up for this substitution, which gives us this integral, which we could solve right away. Now we have to get this expressed in terms of the original variable x. So we go back to our substitution here. Theta will be easy to figure out, because theta would just be the inverse sine of x minus 1. So we have that part. We have to figure out what is the cosine of theta. So, as we've done before, we draw the triangle. And we'll call this theta. Okay. The sine of theta equals x minus 1. Sine of theta equals x minus 1 divided by 1. And that's the side opposite divided by the hypotenuse. So this should be the hypotenuse here. And then this side of the triangle is going to be the square root of 1 minus x minus 1 squared. But we've seen that before. That's this, which is the same as this. So we can write this here as the square root of 2x minus x squared. So we had, when we solved the trig integral, we had 2 theta minus the cosine of theta, and that came from this integral here, x plus 1 divided by the square root of 2x minus x squared dx. So that will equal 2 times theta, that's this, 2 times inverse sine of x minus 1 minus the cosine of theta. Now we go to our triangle. This is our original integral here, equals 2 theta. Theta is this. And then to get minus the cosine of theta, go to our triangle. The cosine of theta is the side adjacent divided by the hypotenuse, which is just 1. So here we have 2x minus x squared plus an arbitrary constant integration, and that should be it. So again, we went to here. We tried out a UDU substitution, couldn't get it to work. So we fiddled around with this, so it resembled this. Then once that happened, that set us up for the substitution here. And then we put all the pieces in place. We got this trig integral, which is really easy to solve. We just do it in our head. The integral of 2 d theta is 2 theta. The integral of the sine of theta is minus the cosine of theta. We could figure out theta right away from our substitution, but to get the cosine of theta, we had to draw the triangle. And then once that was done, we could use the triangle to figure this out, which was this. So that's it. There's no more to it than that. I hope it was helpful. Come back and join us for some more videos, and we'll try and solve some more problems.